Companies can cut AI deployment costs by up to 50% by running models locally instead of relying on cloud services. Local setups require an initial hardware investment, but they offer long-term savings. Let's explore the fundamental cost components of AI deployment. Deploying AI locally involves an initial hardware investment ranging from $600 to $10,000 for GPUs. Cloud services, however, charge ongoing rental fees between 50 cents and $10 per hour. When considering total cost of ownership over 3 years, local setups often prove more economical. The total cost of ownership includes both hardware and operational expenses. While cloud services offer flexibility, they can become expensive with extensive usage. Local hardware setups require upfront investment but reduce long-term costs. Choosing between local and cloud deployment depends on specific business needs. Some companies benefit from the scalability of cloud solutions despite the cost. In the long run, evaluating total costs helps in making informed decisions. To run AI models locally, you'll need a powerful setup. Let's explore the hardware requirements. A key component for local AI is a GPU with 8 to 24 gigabytes of VRAM. For instance, the NVIDIA RTX 3060 is a popular choice for many AI enthusiasts. High-end models like the NVIDIA A100 offer even greater performance with more VRAM. Besides the GPU, a powerful CPU is also crucial for handling complex computations. For RAM, you'll need at least 16 gigabytes, but 32 to 64 gigabytes is recommended. Comparing local hardware costs to cloud instances reveals a significant price difference. A local setup provides consistent performance without the recurring cloud fees. Running AI models locally offers control over data privacy, unlike cloud solutions. Ultimately, your choice depends on balancing performance needs and budget constraints. Consider your specific AI requirements before investing in local hardware. In this chapter, we'll compare the performance metrics of local machines and cloud instances, focusing on latency and speed. Latency is the time taken for a data packet to travel from one point to another, typically measured in milliseconds. Local machines often have lower latency because data is processed close to where it's generated. For real-time applications like video conferencing, low latency is crucial to ensure smooth interaction. Cloud instances can achieve high processing speeds, handling many inferences per second. However, this speed advantage comes with higher latency due to data transmission over long distances. Local setups, despite lower processing speeds, provide consistent performance for applications needing immediate response. Consider a gaming scenario where latency impacts real-time player interactions negatively. In contrast, cloud computing excels at batch processing where latency is less critical. For applications like AI training, the cloud's processing power can outweigh latency concerns. Ultimately, the choice between local and cloud depends on your specific latency and speed needs. Running AI hardware locally can incur significant energy costs, ranging from $100 to $300 monthly. These costs depend on the efficiency of your hardware and local electricity rates. Hardware failures and upgrades can lead to unexpected maintenance expenses. Local AI setups may require frequent upgrades to stay competitive. In contrast, cloud services include maintenance in their rental fees. Cloud services handle hardware failures and updates without extra charges. Consider potential downtime costs when local hardware fails unexpectedly. Cloud services provide redundancy, minimizing the risk of downtime. Long-term maintenance for local setups can become costly over time. In summary, local AI setups may have higher energy and maintenance costs compared to cloud options. Data privacy and security are critical when deciding between running AI locally or in the cloud. Running AI locally offers greater control over data privacy, reducing exposure to external threats. Cloud-based AI can introduce vulnerabilities through shared infrastructure and potential data leaks. Data breaches can be costly, with penalties reaching millions of dollars. Local AI governance models can help mitigate these risks with strict data control policies. An example of local data governance is the use of secure on-premises servers. Avoiding data breaches not only saves money, but also protects brand reputation. Compliance with data regulations is easier with local AI, reducing legal risks. Cloud services may offer flexibility, but require trust in third-party security measures. Investing in local AI security measures can prevent hefty fines from data breaches. Local AI setups can be more expensive initially, but save costs in the long run. Understanding the balance between cost and security is key in AI deployment decisions. Scalability is the ability to grow your computing resources to meet demand. Let's explore local versus cloud options. Scaling locally involves buying and setting up additional hardware, which can be costly and time-consuming. In contrast, cloud computing allows businesses to scale up resources with a pay-as-you-go model. For startups, cloud solutions are often more economical since they avoid upfront hardware costs. Established enterprises might find local setups more cost-effective in the long run due to stable demand. Adding a new server can cost thousands, whereas cloud scaling is often just a monthly fee. A startup might spend $200 monthly on cloud services, while an enterprise might spend $5,000 on servers. Cloud platforms offer flexibility, letting businesses scale resources up or down as needed. Local setups require physical upgrades, which can be slow and disruptive. Cloud computing can dynamically allocate resources, reducing waste and optimizing costs. In summary, the choice between local and cloud scaling depends on specific business needs and budgets. Let's explore real-world examples of companies successfully transitioning to local AI deployment. Company A reduced its AI operational costs by 40% after moving from cloud to local servers. Performance improvements of over 30% were reported by Company B after their local AI transition. However, Company B also faced increased maintenance requirements as a trade-off. Company C, a healthcare firm, saw a significant reduction in data latency by 50%. This reduction in latency greatly improved real-time decision-making processes. Company D, in the retail sector, noted a 25% increase in sales due to better customer insights. The improved insights were a result of quicker data processing capabilities. Despite the gains, Company D had to invest more in staff training to handle the new system. Company E in the tech industry saw a significant improvement in energy efficiency. This move resulted in a 35% reduction in their energy bills. These case studies highlight the potential benefits and challenges of local AI deployment. Let's explore the long-term financial implications of choosing local AI over cloud services. Investing in local AI hardware might seem costly initially, but it depreciates over time. Cloud services, while initially cheaper, can experience price hikes over time. Consider a scenario where local AI hardware costs $10,000 initially. Over 5 years, the hardware depreciates to a residual value of $2,000. Cloud services might cost $2,000 annually, totaling $10,000 over 5 years. Local AI provides a tangible asset that retains value, unlike cloud payments. Depreciation can be accounted for in financial planning, softening the blow of upfront costs. Cloud services lack asset value, but offer flexibility and scalability. In 5 years, local AI can offer savings if hardware retains value. Choosing local AI can lead to significant long-term financial benefits. Conducting a cost-benefit analysis for local AI deployment involves evaluating several key factors. First, assess your budget. Considering both initial investment and ongoing costs, performance needs are crucial. Ensure your hardware can meet the required processing demands. Privacy concerns must be addressed, especially when handling sensitive data. A balanced analysis weighs both tangible and intangible benefits against costs. Consider potential savings from reduced cloud service fees over time. Local deployment may require higher upfront costs for hardware and setup. Long-term savings can be substantial if usage exceeds 100 hours monthly. Weigh the benefits of local control against potential higher energy costs. A sample analysis shows that local deployment can save up to $1,500 annually. In conclusion, consider your specific needs and potential savings when deciding. For businesses with consistent workload demands, local deployment can be cost-effective. Investing in a mid-range local setup like the NVIDIA RTX 3060 offers long-term savings. For businesses exceeding 100 hours monthly, local setups provide significant savings.